Here we have a second example on graphing radical equations. It says y equals the radical or square root of x minus 3 minus 2. I'll go to an xy plane. I always want to find that vertex. The vertex, I'm treating this radical like a set of parentheses. So I'll undo this. I know that the vertex would be located at 3, and then I'll keep this other value, the value on the outside. So it's negative 2. Y is negative 2. And so I locate 1, 2, 3, down 2. That's my vertex. Because this is a positive radical, I know it will open to the right, and I'll be looking at the top part of this. And so when I do my standard movements, I'll go up 1, right 1. There should be a lattice point right there. From the vertex, if I go up 1, 2, I should be able to go right 1, 2, 3, 4. There'd be a point there. If I go up 3 units, 1, 2, 3, I should be able to go 9 units to the right. So 5, 6, 7, 8, 9. And I simply connect the dots, making sure that I show this as a curve. There is curvature there. It's curving out this way. It's the top part of a sideways parabola. And then I would ask you to identify the domain and the range. The domain is a collection of x values. Which x values have been activated for this graph? It starts at 3 and runs to the right forever. So I would say I can actually touch 3. I do a bracket. And because it runs to the right forever, we'll do infinity with the parenthesis, meaning that we can't contain it. Range. The range, the lowest y value I have is negative 2. So I'm measuring that against the y-axis. I say I can touch or contain negative 2, and then it goes up forever. So it goes to positive infinity. I'm going to go ahead and do a third example here. Example 3. Let's see what happens if we do y equals the negative square root of x minus 1 plus 4. I'll go ahead and make my xy plane. And nothing really changes. My vertex is still going to be the opposite of what I see here. So my vertex will be located at 1, and then I keep the stuff on the outside. 4. I'll locate the point 1, 1, 2, 3, 4. That's my vertex. Now, what happens when I have this negative on the outside? Instead of graphing the top part of my parabola, like I did in the first 2 examples, now I'm interested in the bottom part of the parabola. So instead of going up and right, I'll go down 1, right 1, down 1, 2, should go right 1, 2, 3, 4. 1, 2, 3, 4 from the vertex. So there'd be a point here. If I were to drop 3 units down, 1, 2, 3, I should go 9 units. 5, 6, 7, 8, 9. And I'm simply going to connect those points. As I connect the points, I see that that is a parabola. It's the lower portion of that parabola that's been kicked over. When I talk about my domain and range, the domain, the x values that have been activated start at 1 and run to the right forever. So I would say I can contain 1 and I go to infinity. For the range, well, this would be a little bit different because this lowest value that's measured on the y-axis, this thing will actually go down like this forever. So it'll start at negative infinity. You could go as low as you want. So I'm going to do a parenthesis with the negative infinity, and I measure this as it goes up the y-axis. The highest point it ever gets to would be 4 in terms of the y value. And so I would say I can go all the way up to 4. and here's how you would write your domain and range. Please make note that I'm always going from least to greatest value. You can't just put these in here however you feel and say, hey, figure it out. It's wrong. If it's not done correctly, it's wrong. It has to go least to greatest. It's just like when you do your set notations. In fact, this is a special kind of set notation. You go least to greatest, okay? So there's 2 more examples on how to graph radical equations.